Welcome to ZTT Tech Talks. Today we're going to discuss the Gina Development Board software environment. The Gina Development Board has an Atmel AT90 USB 1287 with 128K of internal flash and 8K of internal SRAM. And in addition, there's 128K of external static RAM on the board, which provides lots of data space for your application code. All of the code we've used is GPL or a variant thereof, and we will provide all of our modifications and additions to this code free of charge. Since we have all of the program and data space, there's plenty of room for FreeRTOS and the Lufa USB stack. The Lufa USB stack has been integrated with the FreeRTOS environment. In our case, we use the USB CDC serial port and have made two main Lufa USB serial tasks into FreeRTOS tasks. The analog to digital routines to read the thermocouple are part of the PID task, and for each temperature reading, an A to D sample is taken up to 64 times and averaged, and the processor is optionally put to sleep during conversion. The microSD card software has been leveraged from the Arduino libraries and is used to load images and audio files. The components to implement this are the SPI drivers and the FAT file system. The SPI is used for the LCD, and access to SPI devices is negotiated via a critical section in the code. The 8 or 16 kHz 12-bit audio subsystem is provided by an SPI DAC and a 2-watt audio amplifier. The audio code is based on the Arduino WaveShield libraries, but is heavily modified to work concurrently with the LCD display, microSD card, and other FreeRTOS tasks. The audio is generated by bit bashing SPI data out of a GPIO to the DAC. The display is a Nokia 6100 LCD clone with a resolution of 130 pixels in both horizontal and vertical directions, with 12-bit or 4096 colors. The code was originally based off the code from IDLEloop, but has been heavily modified to support the Philips controller and various Epson controllers. Currently, the type of controller is selected by writing the controller type to EEPROM at programming time. The user interface has been implemented in C++, that is a menu-based system that provides a means to select options and set values either numerically, such as time and date, or with a slider interface for things like contrast and time values. The user input portion of the board features 5 directional navigation push buttons. The Gina also has the option of using a joystick instead. Buttons are read with GPIO code in C++ and can interface with the menu system. USB support is provided with the Lufa USB stack. The CDC serial device is implemented for the PID controller and main application code. It has also been leveraged for use with the bootloader to simplify programming, and as a mass storage driver during initial factory programming of the SD card. The Gina has a Dallas 1307 real-time clock with a CR2032 battery backup for non-volatile timekeeping. A simple real-time clock class reads or sets the time using the Arduino-based one-wire library. There is a board support package that maps Arduino pin headers on the Gina board to the Arduino framework. This allows you to use Arduino Development environment to program the Gina board with simple sketches and use the Gina board with Arduino shields. We have a capacitive sense routine that uses the capacitance of an external circuit as part of the NRC time constant. A change in the capacitance affects how long it takes the GPIO pin to toggle. We use this routine to detect espresso machine water tank levels. To compile the code, all that is required is AVR GCC. In my particular case, I use Eclipse under OS X with Crosspack AVR. To generate fonts for the system, I use GLCD Font Creator in a Windows VM. Images can be created from BMP files with a script that formats the data into 12-bit RGB for direct writing to the Nokia 6100 LCD. Audio files are created by converting any audio format into a 16-bit 8 kHz WAV file with FFmpeg. I have a script that converts text strings into these WAV files using the Mac built-in say command. These voices are proprietary, however, so I cannot include them in the distribution, but a script is available for you to make your own. There are many other ways to create these WAV files. To program the board, any AVR ISP programmer will work. Typically, it is used once to program the EEPROM and USB bootloader. Once this is done, the board can be plugged directly into a PC and programmed over USB with AVRDude. The bootloader is based off the Lufa stack, and more information on it and any required USB CDC drivers for Windows can be found on the Lufa website. Linux and OS X work out of the box with this bootloader. The board ships configured and programmed with either the Coffee or SATA reflow software configured. In addition, the SD card comes programmed with a generic audio file that you may want to replace. See the credits at the end of this video for links to various software packages used and other development tools. Thanks for watching.